Here we go. Number 1. Write the English phrase in algebraic expression. Let x represent the number. So 8 less than means you put a minus 8. 5 times the number means you put a 5x in front. You have to remember that less than means to write them backwards than what you would think. So 8 less than means put minus 8. Evaluate the expression. So where x is, we need to put 3. Where y is, we need to put 9. Do a little bit of fancy order of operations. So exponents come first. Remember that's PIM-DOS, parentheses, exponents, multiplication, division, addition, subtraction. So this gives us 45 plus 36, which is 81. So that's our answer there. Use the order of operations to simplify the expression. So 5 cubed we need to do first because that's an exponent. That's 125. Negative 3 to the 4th power, that's an exponent, so we need to do that. Keep in mind that negative 3 to the 4th power, this is what we're really doing. Now you can type it into your calculator. Just make sure you put negative 3 inside of parentheses with the 4 on the outside. Okay, but since there's 4 negatives here, the negatives will all cancel out and give us positive 81, but we're subtracting that number, so it's 125 minus 81, which is 44. Solve the equation, so let's subtract 3 from both sides. You always want to add or subtract first. The number that's closest to x, which in this case is the 5, that has to be undone last. We go from like the outside to the inside kind of a thing. So 53 minus 3 is 50. Divide by 5 on each side. You get x equals 10. 5-step strategy. I have no idea what the 5-step strategy is. I've made up some 5-step strategies about people being awesome, but ain't nobody got time for that right now. So 20% is 0.2 times what number means times something like x. Any letter will do. Is means equals. 82 means put 82. 0.2 times x equals 82. To undo that equation, I need to divide both sides by 0.2. When I do, that means x equals 410. That's the answer. Number 6. Solve for the specified variable. They tell us to solve for r, which means get r by itself. That pesky t is right next to the r, so let's divide it on both sides. So d over t equals r. That'd be our answer. Multiply using the product rule. Well, negative 8 times negative 8, that's positive 64. And then these x's and y's, we add their exponents together, keeping in mind that a y without an exponent, or any variable without an exponent, would be to the first power. So x to the 5th and x to the 4th become x to the 9th. Y to the 1st and y to the 6th become y to the 7th. There's that. When we divide using the quotient rule, though, we subtract our exponents because it's like we're trying to cancel out, basically. So on the bottom, we've got 3 x's. That'll cancel out with 3 of the x's on top, leaving us with 4 x's. 7 minus 3 is 4. 12 minus 6 is 6, so that's y to the 6th. There's that answer. Use the 0 exponent rule to simplify the equation. 6 to the 0 power is 1. Anything to the 0 power is 1. Please do not put that it's something other than 1. That's just silly. It really is 1. And if you are ever in doubt, your calculator knows what it is, so if you ask it politely, it'll tell you. Write the expression with positive exponents only. So these two things right here that have negative exponents, we need to move them so that they become positive. So the x to the 8th has a positive exponent. It gets to stay where it's at. Y to the negative 5th gets moved down to the bottom and becomes y to the positive 5th. Z to the negative 8 gets moved to the top and becomes positive 8. There's that answer. Number 11. When we have these exponents right next to each other, we multiply them together and we get x to the 10th. Whenever we have an exponent on the outside of a parentheses like this, it's kind of like we're distributing to everything on the inside. So x to the negative 5th becomes x to the positive 5th. We multiply negative 5 times negative 1. Y to the 3rd becomes y to the negative 3rd. And then secretly in the instructions, they don't really tell us to do this. We want to go ahead and write this with positive exponents. So like we did earlier, we move down the thing that has a negative exponent, y to the negative 3rd. That makes it x to the 5th over y to the 3rd. Here we distribute again, but this time we're distributing to the top and the bottom. So m to the 35th over q to the 20th. Good old scientific notation. If this is a negative number, we move the decimal to the left. If we have a positive number, we move the decimal to the right. So we take 6.88, we move it to the left 4 times, and we put zeros where those hump things are. Well, I'm not really... Oh, there's a 0. There we go. Okay, so that's 0.000688. To write a number in scientific notation, if it's a big number, we're going to end up with a positive exponent. If it's a little number, we end up with a negative exponent. Little is what that says, trust me. So we would have to move this 1, 2, 3, 4, 5 times to get 6.3 times 10 to the positive 5, because 630,000, that's a big number. If you are ever confused, $630,000 is a lot of money. So it's a big number. But if you had like 50 cents, 50 cents is not a lot of money. That's a little amount of money. So you'd put a negative exponent, if that was what the problem was. Domain and range. Domain is our x values and range is our y values. So we just kind of split this up into a list. So -1, -11, -3, -5, -10. Range is our y values, so -1, 6, -7, 7, -6. To decide whether or not a set of points is a relation, is a function, all of them are relations. To decide if it's a function, it's not if the x values repeat. Okay, it's not a function if the x values repeat. So that means that, well, here we have these two x values repeating, so this is not a function. Find the indicated function value, you just plug it in for the x's and do a little bit of order of operations. So it's 9 plus 9 minus 4, which is 14. I think. Gonna check that real quick. Yep, 14. The vertical line test to determine whether or not something's a function. Vertical is up and down. Since it goes through twice, it's not a function. If it goes through once, it is a function. That's how that works. To find the domain of a function, we want to set the bottom of the function equal to 0 and solve. So we add 8 to both sides and we get x equals 8. And then we say, okay, well, what really is happening is that this is all real numbers except, and all real numbers is ARN, except x cannot equal 8. Something like that is what we're looking for our answer. Alright, we want to find f over g of -3. So what we're going to do is we're going to put f, which is 5x plus 4, over g, which is 4x squared plus 4x plus 4. But then we're going to plug in 3 where our x's are. And so when we do this now, we're going to simplify the top. 5 times 3 is 15, plus 4, ooh, awkward, that's -3's, not positive 3's. Okay, so -15 plus 4 is -11. Here we would do the -3 squared first, so that's 4 times 9, minus 4 times -3 is -12. 36 minus 12 plus 4 is 28. -11 over 28 is our answer. Here on 22 and 23, there's an important formula. That's that pesky slope formula. Okay, we label x1, y1, x2, y2, and we plug in, so negative 3 minus 2 over negative 7 minus 1 is negative 5 over negative 8. 5 over 8 is 5/8. Here, 1 minus 5, 7 minus 7, it's going to be negative 4 over 0, which we would say is undefined. Okay, because I cannot divide by 0. If I can't do it, you certainly can't do it. So, I mean, just saying. Slope-intercept form. This number out here is your y-intercept. This one in front is your slope. So we start with the y-intercept. Hey, the y-axis is this one, so you put the y-intercept in the y-axis. Negative 2/5 is a slope. You either put the negative on top or on bottom, whichever. And so we need to think of this either as down to right 5 or up to left 5. Those are saying the same thing, and this is a straight line through those points. Since it's an equal sign, remember we do a solid line anytime we have an equals like this. So here we need to solve for y. Okay, can't really graph it. Oh, I could if I wanted to, but I won't. We're just going to solve this for y by adding x over first. So we get 5y equals x plus 30. Then we want to divide everything by 5. So y equals 1/5 x, because in front of x is a 1. Secret 1 there. Plus 30 divided by 5 is 6. And then we can graph. So we go up to 6 and we put a dot-ish there. And then up 1 and right 5. Which it's really hard for me to actually put those on the right dots. So approximately that. Okay. Graph the equation in the rectangular coordinate system. X equals good old negative 4. Hey, this is the x-axis, this one right here. Put a dot here at negative 4. Does it make sense for us to draw a line going this way? I sure hope not. It needs to go vertically. Okay, so there, right there, that's our line. Now with y equals, we go to the y-axis and we put negative 3 as a horizontal line. And the reason this is a horizontal line is there is no x here. So it'd be like a 0x. So our slope is 0, and this is a 0 slope, because if you were a skier on this line, you would have 0 fun. Just none at all. 0 fun. So that's how you can remember that. But what matters is that it did not have an x in it. So we didn't have a slope, so to speak. Here's a good formula. Point slope, y minus y1 equals m times x minus x1. So we have the slope, which is m. We have a point. We do y minus 5 equals negative 3 times x minus 5. Just plugging it in to that formula. And then we try to get y by itself. So we have to distribute. Get negative 3x plus 15. Then we add 5 to both sides. And we get y equals negative 3x plus 20. Find the slope of a line parallel. Parallel slopes have the same, parallel lines have the same slope, so our slope would be good old 1/2. Perpendicular are opposite reciprocals. So if I have negative 3/2 to start off with, I would change that, make it positive, and flip it. So 2/3. Now we're into good old chapter 3, solved by graphing. This line right here, this will be fine. This will be great. We're going to y-intercept at 4 with a slope of up 4 over 1, which I can't do, so I have to go down 4, right 1. And then do it again. The more dots, the better. Because we want to see where are these two things going to intersect. So now I go to negative 3. Go up 1, right 2. Oh, that's not going to help me to keep going this way. I need to go back this direction. Oh, look, that's where they intersect. So this point right here is our answer. That point is negative 2, negative 4. solve the system by substitution, take what x equals and put it into the other equation. That's going to be 8 times negative 5y plus 5 minus 9y equals negative 9. And then we need to, solve this out. So distribute negative 40y plus 40 minus 9y equals negative 9. Add your like terms here. So that's negative 49y plus 40 equals negative 9. Subtract 40. And we get negative 49y. I'm running out of room here. Let's just go off the page. Equals negative 49. And so we divide by negative 49 on both sides. So we get y equals 1. And then once we have y, we want to plug it back into that first equation. X equals negative 5 times y, which is 1, plus 5. So that means that if we figure that out, that's 0. So our answer is the point 0, 1. Solve the system by the addition method. Well, that's also known as the elimination method. And we would figure out what could I multiply one of my equations by so that I end up with the same thing in front of either x or y, but with different signs. So here I can multiply by 3 because that'll give me 6x minus 9y, which is what I want, minus 9. So once we do that, we kind of get rid of that second equation and we add the equations together. That's why it's called the addition method. 7x plus 6x is 13x. The y's cancel, that's what we were going for. 9 minus 9 is 0. It's also kind of like they cancel. Then I divide 13 on both sides, and I get that x is 0. Then I have to go and plug back in to one of my two equations, doesn't matter which one. So like 7 times 0 plus 9y equals 9. So that goes away. 0, divide by 9 on both sides, y equals 1. So this is the point 0, 1. I don't know what that's all about. 34, a college student earned $5,600. College students decide to invest in a 9% and a 7% interest rate, and in doing that they get 460 interest. So what happens is we split our investment into two parts that have to add up to be $5,600 because that's how much money there is. And then there's part that earns 9% interest and there's part that earns 7% interest, and that interest total is 460. Now if you're crafty, since we want how much is invested at 9%, which is at x, because that's where we put the 0.09, if we're crafty, we could do this where we just have to solve for but let's face it, we may or may not be crafty. For example, though, if we wanted to get x as our first answer, we actually would want to solve like this first equation for y. Subtract x from both sides. So that and then when we plug this in here, we get 0.09x plus 0.07 times 5,600 minus x equals 460. So we have to like distribute. Oh no, that math. 392 minus 0.07x equals 460. Give myself a little room here. Like terms, so that's 0.02x. Subtract the 392 over here. So we get 68. Divide both sides by 0.02. And x equals $3,400. So since we were looking for x, we found it. If we had accidentally solved for the wrong variable, you just take that 3,400 and plug it back into the equation to find the other variable. Alright, on 35, this is this right here. Remember our points are our x, comma, x, comma, y, comma, z. So we plug these in. So we have, for the first equation, -1 plus 4 plus 2 equals 5. -1 plus 4 is 3. 3 plus 2 is 5. Okay, that one works. If all of them work, it's a yes. If any of them don't work, it's a no. So -1 minus a positive 4, so that's -4, plus 2 times 2 equals a -4. So -1 and -4 is -5. -5 plus 4 is -1. That does not work. So this is a no and we stop. If it was a yes, we'd have to keep going and do that last one just to see if it worked out or not. 36. Solve the system by hand using elimination. Now this one can seem pretty tough, but it also can be kind of straightforward. Like, I believe you can do this. Let's add these first two equations together, because if we look, if I add them together, the y's will cancel out, because one's a plus y, one's a negative y. So this gives me 2x, the y's cancel, plus 4z equals 6, because I'm adding all of the two equations together. Then I do the second and the third one because of the same reason. I can get those y's to cancel out. That gives me 4x plus 4z equals 4. Now we only have two equations with two variables. So we're going to say, hey, how about if we multiply one of these by something so that we can get another variable to cancel? And so I would look at this and say those z's are really close, but we need to multiply by a -1. So we distribute that through, and that gives us -2x minus 4z equals -6. Cancel out the z's, that gives us 2x equals -2. Divide by 2. We get x equals -1. Once we have 1, it's like a downhill slide from here. We got to take this and plug it back into one of these two equations and solve for z. So 4 times, I'm just going to pick the first one for fun. Well, that's actually the middle one, I guess. So never mind, I'm not picking the first one for fun. 4 times -1 is -4. Plus 4z equals 4. Add 4. 4z equals 8. Divide by 4. Get z equals 2. Now we know two variables. We gotta find that third one by plugging back into one of these first ones before we canceled things out, keep in mind. So x plus y plus z equals 6 sounds easiest to me. So -1 plus y plus 2 equals 6. So that's y plus 1 equals 6. So subtract 1 from both sides. We get y equals 5. Now technically the best way to write this answer is as a three-dimensional point, -1, 5, 2. There, right there is our answer. 37. All it wants us to do here is just write this with x, y's, and z's. We got an x column, a y column, and a z column, and then we put the equal sign, and that last column doesn't have a letter with it. Then on the second row, when we get a 0 for this y right here, we don't need to actually write 0y. We can just like skip it and write then plus 9z equals 4. And then 6x plus 2y there, that 0, we skip that, and then we go to equals 2. And that's it. That's your whole answer. That's all it's asking you to do. Number 38, this is asking us to switch the rows. That's totally how you spell switch. So the second row becomes the first row, and the first row becomes the second row. It's amazing. As simple as that. Now, this is telling us to do 1/4 times row 1. Well, remember, these are our rows, so, well, we're not doing anything to row 2, so it gets to stay the same. But we're timesing everything in this first row by a 1/4. So 4 times 1/4 gives you 1. -12 times 1/4 gives you -3. 20 times 1/4 gives you 5. Bada bing, bada boom. Done. This one's asking us to take -4 times row 1 and add it to row 2. Well, nothing changes about row 1 because we're gonna use row 1, but we're not actually gonna change it like that pesky ex-boyfriend or girlfriend. JK, enter, never mind. -1, 3, -2, -1. Row 3 doesn't change at all because it's not even mentioned here. When we do -4 row 1 plus row 2, I'm going to take each thing in row 1. So the first thing in row 1 is 5. So I take -4 times 5 and I add it to what's in row 2, which is a -4. Well, what is that? That's -20 plus a -4, which gives us a -24. So that's the first thing in row 2. Then we keep going. -4 times, what's the next thing? It's a -5. Plus, what's in the second row, which is 0. Well, -4 times -5 is 20, plus 0 is 20. Keep going. So, -4 times 1 plus 1. -4 times 1 is -4, plus 1 is -3. And then we use the last column. -4 times 4 plus -3. So that's -19. So that right there, that's our answer. Alright, this tells us to solve the system using row operations, and when we do that, we want to try to get ones in our diagonal, a 0 underneath our diagonal, and everything else. We just want good old plain old numbers. So when we do this, we just start off by making a matrix. So 1, 1, -5 is the first row, 1, -1, 19 is the second one. And then we want to say, well, this top left, that's already there. And then we come down here to the next row and we try to get the 0 right here. We want that to be a 0. And so to do that, we can multiply row 1 by a negative and add it to row 2. So that's what we're going to do. -1, row 1, we're going to add it to row 2. And this is kind of like elimination, where we have to like multiply this by something and then add it to something else. So when we do this, the first row does not change. We do -1 times 1, we get -1. We add it to the second row, and we get 0 here. And we do -1 times -1, which is -1. -1 plus -1 is -2. Then we do -1 times -5, which is +5. We add it to 19, and we get 24. So we've got this 0 taken care of. Now we want to get that 1. So to get this to be a 1, we have to multiply basically by the reciprocal of -2, that second row. Okay, if we try to multiply the first row by something and then like add it or whatever, it's not going to work because it's going to change the 0 right here that we already got. So we have to just multiply by something with this number on the bottom. So that's 1, 1, -5, 0, 1. 24 times -1/2 is -12. We are trying to find x, y, and z here. So this is x plus y equals -5. And then y equals -12, because there's no x right here. So y equals -12. We plug that in here. We get x minus 12 equals -5. So add 12 to both sides. X equals 7. So that's 7, -12. Determinant by hand, with a 2 by 2, you take the diagonals, you subtract them. 7 times 6 minus 4 times 7, that's 42 minus 28, which is 14. Use Cramer's rule to solve. Cramer's rule can be kind of tricky. You might want to write it down from our notes or whatever. I guess I can write it down here. And we start off... Sorry, my writing's pretty bad. So a1 times x plus b1 times y equals c1. Then a2 times x plus b2 times y equals c2. that helps us figure out what the A's, the B's, and the C's are, and then we plug those in. C1, C2, B1, B2 on top, and then A1, A2, B1, B2. If you're having problems reading this and you really want it written down somewhere, look in your notes or in your book or on the internet. But please don't come and complain to me because you couldn't read this, because I really don't care. And I mean that in the best possible way. Alright, this tells us what to basically plug in. This is saying, well, hey, here's our A column, here's our B column, and here's our C column. And there's a 1 in front of Y here. So we set up and we say X equals, we've got C1 and C2, so that's negative 18, negative 6. We've got B1 and B2, so that's 3 and 1, over, we got A1, A2, so that's 6 and 2, B1 and B2, so that's 3 and 1. Okay, and then to set up Y, we would do A1, A2, so that's 6 and 2, C1, C2, so that's negative 18, negative 6, and then the same bottom here. Now to solve this, we have to do determinants like what we did on the last problem. So we do negative 18 times 1 minus negative 6 times 3. Well, that actually gives us negative 18 plus 18, which is 0. Then the bottom, we have 6 times 1 minus 2 times 3, which that's 6 minus 6, which also gives us 0. So that gives us 0 over 0, which is undefined. Makes this infinitely many solutions. But if it didn't, we'd just go ahead and keep going. Like we would also do this minus this, this minus this, and we'd just keep solving for x and y. For the determinant, here on 44, that's what this says. It doesn't say instructions, but that's what it wants us to do. You start off by rewriting the first two rows, 6, 3, 5, not rows, columns. First two columns. And then we look at our diagonals. We've got a diagonal right here, which is 6 times 6 times 6. Just kidding. 4 times 5 times 5. Plus 3 times 3 times 2. Okay. Then we look at our diagonals the other way. 5 times 6 times 3, 2 times 5 times 6, and 6 times 3 times 4. And we figure out what these two things are. Like, plug into your calculator, let it help you. Because this is like 216 plus 100 plus 18, which is 334. This would be 72. No, that's 90, 60, and 72, which is 222. Then what you do, because these are diagonals going different directions, you subtract them. Okay, subtract. And that gives you a beautiful, beautiful answer of 112. By the way, don't know if this came up, but you can get negatives for determinants, so don't freak out if that happens. It's totally possible. 45 here, I'd like to see if you can do it. Pick any way of solving this by hand, not just throwing it in your calculator. See what you can come up with. I believe in you. 46, solve the inequality. Write your answer in interval notation and graph the solution set on a number line. So this is kind of like solving an equation. You'd subtract 1 from both sides and get 2x is less than 16. Divide by 2 and get x is less than 8. And then I would graph it. Remember, if it's less than but not equal to, that's a parentheses at 8, and then it's pointing to the left, that inequality, so we shade to the left. And then interval notation from that is, I think, is easier, because over here is negative infinity. So we put negative infinity, comma, we're stopping it at 8. That right there, that's our interval notation. Intersection means, what do they have in common? Okay, so they have in common 2 and 6, so that's D. Solve the compound inequality. So we just need to divide 5 here, get x is less than 1, subtract 5 here, get x is greater than negative 3. So less than 1, that's a parentheses, greater than negative 1, so we're shading in between those. And the interval notation for that is negative 3 comma 1, because we're shading in between negative 3 and 1. Here, whenever we've got these three thingies like this, we need to do the same thing to all three parts. So I'm solving this middle, so I need to add 4 in all of these places. So that gives me 20 is less than or equal to 5x, which is less than or equal to 30. And then I will divide by 5 in all three parts and get 4 is less than or equal to x, which is less than or equal to 6. So when we graph that, that's brackets because they're both equal to. Put a bracket at 4 and a bracket at 6, and we're saying x is between them, so we shade between them. And then our interval notation is 4 comma 6 in brackets. Number 50, union means combine. Combine all the elements. It's like when you get married and you put all your stuff together. So that's D, because that has all the numbers from both sets. 51, solve. So subtract 1. Negative 5x is less than or equal to 10. Divide by negative 5. Oh hey, this is important. When you divide by a negative and it's an inequality, you have to flip the inequality. So it'll be greater than or equal to negative 2. Here you subtract 3, so you get 6x is less than or equal to negative 24. Divide by 6, you get x is less than or equal to negative 4. So we're greater than or equal to negative 2, so that's a bracket, and going that way. Less than or equal to negative 4, that's a bracket going to the left. The interval notation on here can seem kind of tricky, but what we want to do is we want to go from negative infinity to 4, and then from, negative 4, and then from negative 2 to positive infinity. So we end up with two different parentheses, because look, we've got two different parts of our graph. So, I mean, that kind of makes sense if you think about it. The solution set for the equation, we would do two equations whenever we have absolute value. We have x minus 7 equals not positive 9, x minus 7 equals negative 9. We solve them both by adding 7, so x equals 16, and also x equals negative 2. Two answers for the price of one. Okay, anytime we do absolute values, we should get two answers like that. Even when we're doing inequalities. So here, we have one inequality that's x plus 6 is less than 5. On the second one, since it's an inequality, we flip the sign when we make the second one negative. So subtract 6 from both sides, so x is less than negative 1. Subtract 6 from both sides, so x is greater than negative 11. So less than negative 1. Where's negative 1? It's right here. And then we're going to the left from negative 1. It's greater than negative 11, which is here, so we're shading in between, like so. And if we wanted interval notation, that would say negative 11, comma negative 1, because we're in between those two values. Here we've got x plus 1 is greater than positive 9, x plus 1 is less than negative 9. So subtract 1 from both sides, x is greater than 8. Subtract 1 from both sides, x is less than negative 10. So greater than 8 is this way, that's parentheses, and then less than negative 10, that's this way. Our interval notation would be negative infinity to negative 10, and then 8 to infinity. And keep going. 55, graph the inequality. So we graph it like a line, where this is our y-intercept, and our slope would be what's in front of x, which would be 1. So we start at -5, we go up 1, right 1, so since it's equal to, that's a solid line, and it's greater than, so we want to shade above the line, oh crap, whoops, greater than is this direction, so there's our answer there. For 56, we want to start off by solving for y. So we just take that x and move it by subtraction. Y is less than -x minus 6, so we go down to -6, which is like there-ish. Negative x is like -1 over 1, so that's down 1, right 1, so that's this way. It's not equal to, so that's a dashed line. And look, it's less than, so we shade below, which is this direction. X is greater than -5. Go to the x-axis. Find -5. It's a vertical line, and it's dashed because it's not equal to. Think about it. Where are the numbers that are bigger than a -5? Well, that's to the right. This direction. To the right, to the right. Y is less than or equal to -4, so you go to the y-axis where -4 is, and now it's a solid line at y is -4, and it's less than, so you shade below. This is going to be tough because of precision. Hello. Alright, so this first line, y-intercept of 1, so we put a dot at 1. Slope of 4, so that's 4 over 1. Rise 4, run 1. This is going to be a solid line. Alright, so that's that line that starts at 1 and goes up 4 over 1. This other line starts at a +0, so we put a dot at 0. And then we go up to right 1, up to right 1, up to right 1, up to right 1. And same that way the other direction. And then we draw that line. That's a dashed line because it's not equal to. So, can't make a dashed line like I made the solid line. Okay, now here's the thing. It's less than the purple line, which means that we would shade this direction from the purple line. But it's greater than the blue line. Greater than the blue line is this way, because it's above that line. So we have to say, hey, where do those overlap? They overlap right here where I'm shading in green. So that would be our answer. So for 60, we take each of these points, which are x's and y's, and we plug them in for z. So like this 2, 5, which is a point, you do 2 plus 6 times 5, and you get 2 plus 30, which is 32. Then we do 4, 2. So 4 plus 6 times 2, so that gives us 4 plus 12, which is 16. Then you do 3, 3. So 3 plus 6 times 3 is 3 plus 18, which is 21. And you're looking for the maximum value of those three, which is 32. 61, the degree of the whole polynomial is the biggest exponent, so the degree is 6. The leading coefficient of the whole polynomial is the thing that's in front of the x there at the very beginning, and that gives us -3. Add those polynomials together. So what we do is we just add like terms. So -4 plus x to the 5th, 7x to the 5th is 3x to the 5th. 2x to the 4th plus a -4x to the 4th is -2x to the 4th. 8x cubed plus 4x cubed is 12x cubed. -1 plus 3 is a +2. So this is our answer right here. one thing changes. If it's a minus sign, we change all of the signs in the second parentheses. So if it's a negative, it changes to a positive. If it's a positive, it changes to a negative. Then we do the same thing we just did and add like terms. So 3x to the 6th plus a negative 9x to the 6th is negative 6x to the 6th. 8x to the 5th plus 5x to the 5th is 13x to the 5th. Negative 6x to the 4th plus 9x to the 4th is 3x to the 4th. Negative 7 minus 9, negative 7 plus 9 is plus 2. I almost went back to my original problem. That's like rookie mistake number 1. So don't let that happen to you. That's our answer. Multiplied. So this is like a distributive property thing. Negative 3 times negative 5 is 15. Add your exponents, so that's x to the 12th. Negative 3 times 12 is negative 36. X to the 5th and x to the 6th make x to the 11th. Negative 3 times 5 is negative 15. I have no x's to put together, so that stays x to the 5th. Find the product. What we have to do here, we can't FOIL. This has too many terms to FOIL, this last one. So we distribute the x through first. And then we distribute the 5 and we add like terms. And if you set it up this way where when I did the second one, I moved it over one to the right, look, we've got like terms all lined up and ready to go. 8x cubed plus 49x squared plus 49x plus 20. Now here it says to FOIL, so we should probably FOIL. Just like as kind of a general rule, if it says to use a certain method, it's probably a good idea. So FOIL is first. X times x is x squared. Outer. X times negative 7, which is negative 7x. Inner, which is 10 times x, which is 10x. Last, 10 times negative 7 is negative 70. In the middle here, we've got like terms, so that's plus 3x minus 70. That's our answer there. 67, you can use a rule for the square, but let's face it, that rule is kind of annoying and sometimes gets us into trouble, so just write it twice and then FOIL. It gives us x squared plus 12x plus 12x plus 144. If you actually FOIL it out like you should. Notice, 12 plus 12 is 24. It does not cancel out because they have the same sign. If they were opposite sides, sure, yeah, it totally would cancel out. They don't have that though, so don't cancel where you can't cancel. Factor the greatest common factor from the polynomial. So we need to say, what do these all have in common? What can I divide all three of these numbers by? You might say 2 and you'd be right, but there's a bigger number. You might say 4 and you'd be right, but there's a bigger number. 8 is actually what we can take out. And so what we do is we write down 8. Okay? And then we say, well, how many x's can I take out? The smallest one has an x squared, which means we can take out x squared. Then it's like we're dividing each of these by 8x squared and seeing what's left over if we divide. So this first one would have 2x to the 7th. Remember, we subtract exponents when we're dividing. So 2x to the 7th. And then negative 32 divided by 8 is negative 4. Subtract those exponents, get x cubed. 40 divided by 8 is 5. X squared over x squared cancels out. So here's our answer. Good old factoring by grouping. Look at these first two. What do they have in common? X squared. They have x minus 5 left over. What do these two have in common? They have a 3, but if we actually want to take out a negative 3 so that we can get x minus 5, because if these match up, we can write this as x minus 5 times x squared minus 3. Factor the trinomial. For some reason people forget how to do this. Even though this is one of the easier problems, it just kind of slips your mind because all it tells you to do is factor. It doesn't really give you any hints. We want to multiply, we want to pick two numbers that multiply to get 35 that will add to get us negative 12. And of course you're all thinking, hey, negative 5, negative 7. This doesn't ask us to solve. There's no equal sign, so we're done there. Don't try to take it further. That's it. Slide and divide. You slide the 7. Gives you x squared minus 31x minus 140. We have to figure out what do I multiply together to get negative 140 that when I add, or really in this case subtract, it gives me negative 31. Let's say you're not very good at this whole factoring thing. In your calculator, if you do 140 divided by 2, gives you 70, which means we know 70 times 2 is 140. Subtract those, you don't get 31, so that's not it. 140 divided by 3. We're just going to keep going until we figure it out. 140 divided by 3, that's a decimal. 140 divided by 4 is 35. So we look at 35 times 4. We subtract them. Oh, we could get 31 that way. So that's what we need. We need to make the 35 be negative so that we can get a negative 31. Very important. We keep forgetting the divide part. Look, it says slide and divide. We slid. Have we divided? No, we haven't yet. So divide both of these by a 7 and simplify. This becomes x minus 5. We can't simplify this, so we move the 7 in front of x and get 7x plus 4. So there's that answer. Factor the difference of two squares. Well, if I can square root both of these, then that means I can split it up into what they are when you get the square root. But you have to write it twice, once with a positive and once with a negative, like this. It is not just 3x minus 5. Does 3x minus 5 equal 9x squared minus 25? No. But if you were to FOIL this out, you would get 9x squared minus 25. Whoo doggy, we got this last problem, these last two problems left here. 74 has a formula, and there's two of these formulas, so I'll write them both. It depends on if there's a plus sign or a minus sign in the middle as to which one we use. This is a plus sign in the middle, so we actually want this next one. A cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And here's how this works. We have to figure out what a and b are. We've got x cubed, which is right here. So x cubed, that means a would equal x. B cubed, we need to figure out what is the cube root of 729. Ooh, that's a rather large number. I don't know the cube root off the top of my head, so let me just go and plug in my calculator and go to the math button. And somewhere around like option 4 or 5, I don't know, it says cube and it has a square root, opens a parentheses. So you press that button and then you type in 729 and it tells you that it's 9. So B is 9. Then what we do is we fill in this side. So we need to have A minus B. Well, A is x, B is 9. Okay, A squared, so that's x squared, plus a times b, so that's 9x, plus, what is b squared? 9 squared is 81. That's our answer. Make sure that you write those formulas down though, or you won't have them. Factoring to solve, so factor this into two parentheses. And you say, what do I multiply together to get negative 16? That adds to get 6, so plus 8 minus 2. Then we add a step basically. We set each part equal to 0 and we solve. So x equals negative 8 and also x equals 2.